Hey, so even if you're not in security lately, you probably have heard of just breaches, data breaches everywhere. It's a data breach after data breach after data breach, after mage cart, after data breach, after credential stuffing, after data breach, after password spraying, data breach, data breach, data breach, mage cart, credential stuffing, credential stuffing, credential stuffing, data breach, data breach, data breach, data breach, data breach, data breach. There are data breaches every single week, at least, if not multiple times a week. Why? Why are we hearing so much about so many types of data breaches? Well, there's actually a pretty good reason for that. And let's get to it. So I talk a lot about security stuff. I talk a lot about credential stuffing and password security, web security, stuff like that. And I inevitably come across people who think that something has already been solved, that there's already a silver bullet for some vulnerability or problem or something, and you're just magically going to be secure. Or I come across another group of people who just think that there are simple solutions to problems, and if they just had enough time or prioritized right with their team, they could take care of it. And that's not the case, because when we're talking about attackers and why people attack, it's not as simple as just solving that, because you're talking about people. You can't solve people. These are real people that are financially motivated to commit these attacks and get enough value out to offset the cost. Now, think about value for a second. Think about where you work, what you do, and what value surrounds your work. Chances are you're probably working at a company, maybe even a big company, and your job is to increase the value of the company. Now, as your company increases value, that increases the value for an attacker to extract data or something out of that company. And if you have a company that's based around users, then as your company grows more valuable, then each individual user becomes more valuable, and it makes it more likely that an attacker will target those users for something. It doesn't matter what attackers are doing with the data. It's gotta be valuable to somebody. And if the cost is low enough, then it doesn't even matter what the possible value might be, because attackers will just attack you just to see what they get out of it. So that brings us to the entire concept of rate of return. Now, I've started to describe this with metaphors because, well, they're fun and I can use different pictures and stuff. So we're gonna talk about a carnival game as our metaphor here, because it's actually pretty similar to an attack against your company or website or whatever else. You have the cost of playing the game, which is the cost of issuing an attack. You have the prize that you get from the carnival game, which is analogous to the value you get from breached accounts or stolen data or something along those lines. And then you have the chance of success. Not all attacks are going to be successful. There is a very, very high likelihood that you will fail. So you need to figure out the cost of, or the rate of return for a chance-based game like this. Now, with this carnival game, let's say it's one of those games that you throw a ball and it lands in a cup or something like that. I'm sure we can find a picture for it somewhere here. And then you have the cost of playing the game. So let's say that's $1 for our example here. You have the value, which in this case is, let's say a pink gorilla. And this value is something that you're gonna have to decide for yourself. It might be that you could pay $10 and get that pink gorilla shipped to you on Amazon, but you also might not need a pink gorilla, which means that this pink gorilla has zero value to you, and there's no point in you playing the game because you're never going to get a positive rate of return. Now, on the other hand, you might have two kids tugging at your pant legs here, and that might actually increase the value because it's right here, right now. your ability to win that pink gorilla for your kids might increase that value to 2, 3, 4x its actual value. And that's okay, but you need to figure out that value yourself, just like you need to figure out the value of your accounts and your data. So now that we have all this input, we have the value, our prize in this case. We have our cost, which is the money we're actually going to spend to play the game, and we have our chance of success. That's all we need to start calculating our rate of return. So our rate of return here can be calculated by multiplying the value by the chance of success, dividing that by the cost of playing the game in the first place, subtracting our initial investment, and at the end of all this, we get our rate of return. So for a pink gorilla that has a value of about 10 bucks, a 1 in 10 chance of winning, and a cost of $1, we have a rate of return of 0%, zero anything. And that's not necessarily bad. It just means that over time, we're going to get enough pink gorillas to offset our cost. And that might be exactly where we want to be in life. I don't know. You do you. But now let's say if we raise the value of that, then it raises our rate of return. So if we bump up the value of that pink gorilla to 20 bucks, we're going to get a rate of return to increase about 100%. So this is a great place to be. Like if you're playing a chance game at a carnival, or if you're sitting down at a table with cards, playing poker or something like that, if you have your odds in your favor, then you keep playing until your odds dip below 0, because you are going to get rich over time. Now on the other end, if we increase the cost of playing or decrease the chance of success, we're going to see our rate of return decrease. And if our rate of return decreases below 0, then no matter what, eventually we're going to go broke. So now this is, at the core of it, exactly why data breaches and attacks are exploding. It's because the value is astronomical and the cost is virtually 0. So let's take, for example, let's say that you never patch. So you have services that are up there. You get like Apache, WordPress. You've got ports open. You've got open to the world. You don't patch anything. You don't block anything. What you've done is make it incredibly cheap for anyone to attack you. Because all they need to do is scan all your software, scan all the versions of all your software, figure out if there are any known vulnerabilities for those versions, and then find the known exploits for those vulnerabilities and just run them. That's it. There are tools that actually will automate this process for attackers so that you don't even have to have a brain behind it. You just press a button, walk away, and eventually you're in a system. And then what you get out of it is just pure value. So this is the equation that we need to be playing with more when we're thinking about how to demotivate and disincentivize attackers from ever attacking us. It's all rate of return. We need to make sure that it costs enough and the value is reduced enough so that there's just no point in attacking. So we're actually going to be going through this over the course of several episodes in the series in order to talk about the cost versus value and rate of return for example types of attacks. We'll go into attack detail on how easy it is to perform credential stuffing attacks. We'll go through how to get combo lists. We'll go through some of the tools that attackers use in order to execute these attacks. We'll go through a lot. So if you like this stuff, then subscribe, hit the notification thingy, and we'll see you next time. Thank you. Bye.